In number 11, A and B, it says to show algebraically that f and g are inverses. The nature of inverses is that whatever one function does, the other one must undo. So no matter what you put into your inside function, the outside function has to undo it and bring you back to the original input. To show this, you can't do it with a single value. Show means to prove, and to prove means you have to show it works for all values. So in order to do this, it was a two-step problem. We had to figure out that f of g of x will return a value of x, and to show that g is the inverse of f, we want to show that g of f at x returns an output value of x. So we have two different things we have to do here. We have to find f of g of x and make sure that no matter what g does, because g is going inside first, whatever g does to the function's value x, f at x is going to undo it and brings back to x. And the same thing over here, we want to prove that g will be the inverse of x, because no matter what we put in for x into function f, g is going to turn around, take that, and bring us back to an x. So that's what I'm setting out to prove, so no matter what my input is. So we're going to put inside of function f, g of x, which means inside of function f, and f is 4 times x plus 9. I'm going to take out the x and put in g of x. So that means f at x minus 9 divided by 4 would equal 4 times x minus 9 over 4 plus 9. I want to reduce this and make sure that f will undo g. Well, what I want to do is I want to use my principles of fractions. I can reduce common factors, which will get me to an x minus 9 plus 9, and a minus 9 plus 9 cancel. So what I'm left with is x. So I put in an x into function g. G took that function, and it took x minus 9 plus, or divided by 4. F then took it times 4 and added 9, and when we do that, it returned the value of x. So it undid it. It completely unraveled it. So now we're going to prove that g also will undo f. So now we're going to put into function g, function f, which is 4x plus 9. That is going into function g, which is x minus 9 divided by 4. So I'm going to take out the x and replace it with 4x plus 9 minus 9 divided by 4. So I made this substitution for x. Well, I can get rid of those parentheses. They weren't really necessary. I wanted to redo that. Okay. So what we have is 4x plus 9 minus 9 divided by 4. I just want to get rid of those parentheses. They're not required. The plus 9 minus 9 reduce to 0. So it's 4x divided by 4, which is reduced to x. So we have another function that gives us, no matter what we put into function f, f is going to take it times 4 plus 9. It's going to then go into function g, which subtracts 9 and divides by 4 and returns a value of x. So since both of those return a value of x, they are inverses, and I've just shown that no matter what the input is, it's very general, the output will be the same value we put in, so they undo each other. Inverses.